Okay, just a bit of a reminder. So any shape that stays the same shape all the way through, so for instance this triangular prism, if you took it down to the local bakery and got it put through the bread slicer, every single slice of bread would be that same triangle. And importantly, that triangle on the end and that triangle on the other end are both equal to each other. Rectangular prism, well, for instance, the bottom and the top are the same, so that makes it a prism. Rectangular prisms are interesting because it wouldn't actually matter which way we cut it. It would be a prism. Similarly with a cube, we've got two faces exactly the same, so it's a prism. And similarly with this hexagonal prism, you've got these two faces exactly the same. Okay, the type of prism is normally named after the shape of that constant area, what we'll call the cross-section here. So here the cross-section is a triangle, so it's a triangular prism. Here the cross-section is a rectangle, so it's a rectangular prism. Now here, this is actually one of the types of square prism, but if all of the sides are the same length, we've got a more specific name, which is a cube. But you can also get a square prism. So for instance, if you had a square here and another square up here, and they just joined those sides, it's not a great drawing, but you get the idea, that would be a square prism rather than a cube. Now, what we just said with a prism is you've got two opposite faces exactly the same as each other. If we start with one shape and come up towards a point, then what we've got here is a pyramid. Again, it's named after the shape of the base. So here we've got a rectangle on the base, so it's a rectangular pyramid. If we were to take it again and sort of cut it in a bread slicer, so sort of cut it that way, each slice would still be the same shape as the base, but each time it gets smaller the closer you are to the top. So you can see how all of those slices are exactly the same shape as the base, but they get smaller. That's the same for all of them. Even this one here, if we were to cut it sort of about halfway up, we still get that pentagon, but it's just reduced in size as we go up. Okay, now when we cut a shape, normally we're interested in something like this, so cutting it parallel to the two end shapes and seeing what we get, even with the pyramids we just looked at. But depending on the direction that we cut it, we can get some other interesting cross-sections here. So here, if we take this cube and cut it vertically, doesn't matter where we cut it, we'll always get a square cross-section. Because it's the same all the way through, we call it a uniform cross-section. Similarly, if we cut it horizontally, we'll always get a square, so again it's uniform. If we cut it at an angle, depending on where we cut it, we're going to get these different rectangles. So here if we sort of cut sort of from this centre through to the other centre, you can see this, we get this rectangle, but if we made the same cut up here, you can see we'd get a different rectangle. So that's a non-uniform cross-section. And again, it wouldn't matter which angle we cut it at there. But look, if we cut it at a really weird angle, we can actually get a triangular. So if you sort of cut through the middle of the cube like that, you get a triangle. But if you kept that same angle and came towards the end, depending on where you cut it, you can get these really weird shapes. So here if we sort of cut there, have I done, no, I've done that the wrong way, haven't I? You get some weird shape like this. So here's a better diagram. Depending on your angle, you could actually end up with a hexagon as a cross-section out of a cube there. Okay, again, we're just going to start by naming some of these solids. So here we've got just a cylinder, which we've met before. Here we've got a cube. Look, you could also count this as basically as either being a square prism as well. If rectangular prism was, oh, it's listed there. So look, A is the best answer, but look, really, you could say that if we had square prism, so D is also okay. It's also a type of rectangular prism, but A is the best answer there. And here we've got a pyramid. It's coming to a point, and that looks like a rectangle to me, so I'm going to go rectangular pyramid. Have we got that? Yeah, rectangular pyramid, which is F. Okay, here what we've got is some, and sorry I didn't enlarge these images by the way. Here we've got some solids and we've cut them in different ways. So if you took a sphere and cut it across the centre, that cross-section there is going to be a circle. If we've got this hemisphere, so this half sphere, and we cut it down the middle, the cross-section there is going to be a semicircle. Here we've got a triangular based pyramid. If we cut it parallel to that face, we get another triangle. Let's put it down there. I'm running out of space. And here we've got a truncated cone. So, you know, we had a whole cone and we've cut the top off there. And you can see that any cut that we make parallel to that base will also be a circle there. Okay, so there's 3 pages of exercises today. Okay, again, we're just going to be matching these shapes here to the different names up there. So here we've got a triangular base and it's coming to a point. So it's a type of pyramid. It's a triangular pyramid, which is G. Here we've got a prism. It's staying the same shape all the way through, and the end is a rectangle. So it's a rectangular prism, which is C. Here we've got a pyramid. It's coming to the point, and the base looks like it's a square. So I'm looking for a square pyramid, which is E. Here we've got a cone, which is I. Here we've got it's a square and it's a prism, so it's a square-based prism, which is D. And lastly, again, we've got a prism. It stays the same shape all the way through. The end is a triangle, so we're looking for a triangular prism. Okay, so what we're going to be doing with these shapes is we're going to be shading the base. So here you just shade that in. And we now need to name the prism. Well, that looks like it's meant to be a square. So I'm going to write, well, we could write square prism, but each edge looks like it's the same. So I'm going to write cube there. Here the base, we've tried to draw rectangles, and it is a prism. So I'm going to go rectangular prism. Okay, here the base is going to be a triangle and it stays the same shape all the way through, so I'm going to go triangular prism. Here we've got a 6-sided figure, so a hexagon there. Again, it stays the same all the way through, so we go hexagonal prism. You notice we just write hexagon and we write AL at the end. Now this one here, you've got to be careful because the base is actually on the side here. This is the side that stays the same, and that's a trapezium. Now look, the correct name for that is a trapezoidal prism. Don't worry if you haven't spelt that correctly, it doesn't matter. Okay, and lastly, again, our base is on the side. It's that triangle that stays all the way through. Again, it's staying all the way, stays the same shape all the way through, so it's a prism. Okay, we now need to name the shape of the cross section. So if we've got a cylinder and cut it parallel to the base, we get a circle. If we take that same cylinder and cut it vertically, you can see we actually get a rectangle as our cross section. We've got a rectangular based pyramid, and if we cut it vertically, you can see we end up with a triangle. Same thing with a cone. If we cut that vertically, we get a triangle. With this truncated cone, this shape here, so those two sides are going to be parallel and those sort of are going to be slanted in. So that's a trapezium. And here we've got it's a square-based pyramid which has been truncated. We sort of cut it there, and again we're going to end up with a trapezium, the way it's cut. We've got that same truncated square-based pyramid, but this time we've cut it parallel to the base, so we just get another square, just a bit smaller than the base. Here we've got something you'd call that maybe a sector pyramid, something like that. Sector prism. Doesn't really have a name. But here you can see that cut is a rectangle. And here again, just the way this is cut here, it's going to give us another trapezium. Okay, so we just need to complete these drawings. So here you've got the front face, and we've just got this line going back, and importantly you notice that it goes across 2 and up 1. What we're going to do from each corner is we're going to go across 2 and up 1 and draw our line like so. Again, across 2 and up 1, draw it like so. Then all we need to do is just join those edges that we've just done, and we've drawn out our rectangular prism. This line going back, it's gone across 2, 4, 6 and up 2. So again, we're going to go across 2, 4, 6 and up 2. We draw that line in there. And again, just draw those lines at the back like so. Here, this line here, it's gone, 5 and up 2. So again, from this corner, we'll go across 5 and up 2. From this corner, across 5 and up 2. Draw those lines in like so, and again just join those edges together. Here we've just come down 4 lines, so we just come down, down 4 squares, so we come down 4 squares from each corner, and that hasn't worked. I've just gone down 5. Okay, then just join them up like so. Again, same with the next one, come down 4. Again, just join those up. Okay, and this last one again, across 2, up 1. From this corner, across 2 and up 1. So do it from each of the 4 corners, 5 corners there, the 4 extra corners if you like, and just join them up like so.